So welcome back to the lecture, and in this lecture let's do an exercise. So we are going to do HSI measurement. Okay, so write a program to output HSI clock on a microcontroller pin and measure it using oscilloscope or logic analyzer. So don't worry if you don't have any oscilloscope or logic analyzer. So basically I will be using logic analyzer to measure the HSI clock of the microcontroller by outputting that onto a microcontroller pin. So even if you don't have any measuring things, then don't worry, just follow these lectures, and when you have access to those things you can always recheck. Okay, great. Now let's start. There are two important steps you have to follow to do this exercise. Now the first one is select the desired clock for the MCOX signal. Okay, so there is a signal called MCO in the microcontroller, especially in the STM32 microcontrollers. Okay, MCO stands for microcontroller clock output signal. And the step 2 is output the MCOX signal on the microcontroller pin. That's it. So when we code for this exercise, then things will get clear. Don't worry about that. Okay. So now if you take a look into this clock tree diagram once again, so there are two signals in the microcontroller, MCO1 and MCO2. So these signals we can output on a microcontroller pin. So in this exercise, what we are going to do is we are selecting a clock source for this MCO1 or MCO2 pin. Since we want to output HSI, here it is. This is HSI, right? So HSI comes over MCO1. So now this is disabled by default. So if you want to enable that, so you have to go to the system core, go to RCC and enable MCO1 and MCO2. So now it is enabled. So I'm just showing this for the demonstration using CubeMX software. You need not to do this. Anyway, we are going to write code from scratch. So HSI can come over MCO1 signal. Remember that this MCO1 signal is not a microcontroller pin. It's a signal which is inside the microcontroller, and that signal you have to route it to a microcontroller output pin. That's all you need to do. And you can divide this clock before outputting. For example, there is a HSI and I can divide here. So if I divide using this divisor, then you can bring down that HSI clock output. You can connect this signal to some other microcontroller to provide the external clock. So first select which clock you wish to bring it on MCO1 signal. So that is HSI. This is configured through a register. Let's explore that register. Let's go to the reference manual and go to the RCC section once again. Here is the RCC section, and in the RCC section there is a register called clock configuration register. And in the clock configuration register, so explore MCO1. Let's go to the bit position 21 and 22. Here it is, microcontroller clock output 1. This is a clock source selection actually. So you have to make sure that these bits are zeros. In that case, HSI will be selected. So if it is 0, 1, then LSE will be selected, which stands for low speed external oscillator. If it is 1, 0, then HSE is selected. So make sure that these bit positions are zeros. That is the first step. And the second step is, so you have to bring out that MCO1 signal on the microcontroller pin. So now for that, what you should do is you have to explore pin details of the microcontroller. In order to explore the pin details of the microcontroller, you should not use the reference manual of the microcontroller. You should be using the data sheet of the microcontroller. So all the pin details, electrical characteristics, and other things are described in the data sheet. And the reference manuals usually talk about various peripherals, the peripheral implementation, the register sets, register configuration. So all these things are described in reference manual. So now let's go to the data sheet of the microcontroller. Let me open the data sheet. Here it is. So here, go to pin description table. So here it is, pinouts and pin description, and go to alternate function mapping. So about alternate functionalities and why it is required and all those things you are going to learn later when we start writing drivers for different peripherals. So that will be covered in part 2 of the course. So even if you have any doubts, it will get clear when we discuss about GPIOs and its various modes, alternate function configuration, etc. So now in the alternate function mapping, so just search for MCO1. So let's search this. So here it is. So this is alternate function mapping and there is a signal MCO1. So now let me explain what is the meaning of this table. So now this table describes different alternate functionalities of a microcontroller pin. So here you can see that there are 16 modes are possible from AF0 to AF15 for a microcontroller pin. So this is kind of multiplexing. So you can multiplex different functionalities on a microcontroller pin by changing its mode, or what we call as alternate function mode. You are going to understand about alternate functionality mode in the GPIO section. So even if you don't understand, then don't worry about that. We have an in-depth discussion on these things. So now here, MCO1 is actually an internal signal of the microcontroller, as I said, right? This signal can be mapped on GPIO port A, pin number 8, if you keep its alternate function mode as 0. So that's the meaning of this table. If you keep GPIO port A pin number 8's mode as, let's say, AF4, that is alternate functionality mode 4, then this pin behaves as I2C3 clock signal, right? So these are the different pins of a GPIO port A. A port in a STM32 microcontroller has 16 pins. And microcontrollers communicate with the external world over different ports, such as port A, port B, port C, and so on. So, and please note that this is not the pin number of the microcontroller. So this just tells you that this is 8th pin of the GPIO port A. That's it. If you want to see what is the associated microcontroller pin number for this, you have to refer to the pin and ball definitions. Let's go there. And here you can search for PA8. Right, here it is. So PA8 means pin number 41 in this package of the microcontroller. So microcontrollers come with different packages like LQF64, LQF100, LQF144, BGA, etc. So these are different packages. So if you are using a microcontroller of package LQF-P64, then GPIO port A pin number 8 comes over 41st pin number of the microcontroller. So if I take a look into the schematic of my discovery board, then I can see that. So on the microcontroller, PA8 actually comes over 67th pin of the microcontroller. So that means 67. So PA8 67, here it is. So that means discovery board is using this package LQF P100. So where 100 stands for number of pins of the microcontroller. Now let's start coding. So the step 1, select the desired clock for the MCOX signal. So we actually found out that this has to be done in the RCC configuration register, right? Clock configuration register. And second one is output the MCO1 signal on the MCU pin, and this happens to be PA8. Now we'll code for this in the next lecture.